Hello, my name is Samuel Kimi bin Muhammad Yusof, and so today we're gonna talk about Lab 1, which is ARM Assembly Language, Programming, Data Transfer, Data Processing, and Addressing Mode. So, our objective for the lab is to write assembly language program for the ARM microcontroller using data transfer and data processing instruction and addressing mode. The second one is to execute the program using an ARM kernel to assemble or simulator. So the first question is, write the program that will store 0x30 into R0, copy the content of R0 into R5, and then save the data 0x45785612 into memory location of 0x40000030. Execute the program and explain the difference in the result. Also, discuss the addressing mode of each instruction. So the answer for this question is, so today we use the MOV R0, 0x0 with each immediate addressing. The second one, if MOV R5 into R0 register addressing, because the value of the R5 are saved with the R0, which is 0x30. Also, we use LDR R1 0x40000030. We add it to the register, and LDR R2 also 0x45785612, which is we locate into the register address, and we use STR R2 R1, which is indirect addressing immediate offset, which is the value of the R2 will go to the R1. So we will put first, and then we debug. So we use the value of 40000030 into the memory. So the first value we put in the cursor and then step in. So the value of R1 is 40000030. Also in the register also 40000030. So the value of R2 in addressing also the same. So which is 45785612. It also says 45785612. So the value of the R3 don't have, and we go to the value of the R5 also don't have, but we use store R5 R2. So the value of R5 also 0x30, because we use the register addressing and get the value of 0x30. So in the STR R2 into R1, we got in the memory location, which is 12567845, which is the MSB of the R2 and LSB of the R2 also, and then we get in the memory address, and each of the memory are 8 bit. So the question of number 2 is, write and execute the program that will add 0x20 F690, 0xFE123 089, and 0x34589710, and save the sum in the register R7. Record the change in CPSR as well. So firstly, we use MOV R0 R7 0. So because the first indication line is we want a 0 to be a 0. So the second LDR R1 0x20 FE5690. So we want this value of R1 32 bit into the register R1. So the same with R2 also, 0xFE1230089. So we want also in the register LDR RT 0x34589710. So this one we use ADDS because we want to check in the CPSR as well. So the value of R1 and R2 we add and we restore into the R7, and the ADCS also we want the sum of the value in R1, R2 and R3. So we debug first. So in this value, the value of R1 in the register are same with here 0x20FE5690, and also the value of R2 are same because we use LDR R2 0xFE123089, and we register addressing into the R2, and we use, and the value of RT also LDR R3 0x345389710. So the value of R1 and R2 we might add and use ADDS to check the CPSR and store into the R7. So the value of R1 plus R2 I'll get 1F 108719. So the value of n also n equal to 0 because the value of n equals to 0 because the value of 1 is less than 7. So to get n equals to 1, the value of 1 in 32 bits in binary number must up than 8 hexadecimal number, which is more the 100000001, and can get the n equals to 1. So the z equal to 0 also because the number in this one don't contain the 0 number, and the c equals to 1 because the value of 2 and the value of f added and get the number in the value, and this is example that get. So the value of 2 and value of 8 we got one number in this. So the value of c equals to 1. So the value of z also the value of v are equal to 0 because when we added the 2 and f in the 3-bit or 4-bit, the value in this is not 11 or 00. So the second one we use ADCS because we want the sum of R7, we want the sum of all the value. So the value is 53691E20. So the value of n, like I say, they are not greater than 7. So the value is 0. The value of z also is 0 because the number that we get are not 0 in it. So the v value also did they get because when we sum we sum the value of the previous one and the R3 are now get the 5 value like the previous one, and also the v also did they get in the 3-bit or 4-bit are not 11 or 00. So the third question is write a program that will store 082936 FEDA in R8 and then perform the following result on the content of that register 4 times. Comment in your result. So we want ASR, LSL, and ROR. So the first one we use LDR R8 0x2936FEDA. Also this ASR we use R0 R8 and we'll shift 4 times into the right. So same with LSL and ROR. So you debug. So we use the register addressing 0x2936FEDA. So we to type this. So the value of RH which we get in this is 2936FEDA because we use a register addressing and we register it into the register. So the second one R0 we get 0x02936FED. We got 0 in MSB because we imagine in these two are 0010, and when we shift to the right 4 times, the last value of the value are 0. So the value of 0 are get and put in the MSB. Also same with the second one, we use LSL, R1, R8 and 4. We use shift to the left 4 times and the value are same like the previous one. So the value are get to 0 because the value of the 0010 when we shift to the left are also get the 0. And also the third one is ROR, R2, R8 and we rotate to the right 4 times. And when we use that, the A we put in the front and then we get the A2936FED. So the question 4 is we want to write the program that will perform a logical OR 0x6398 with 0x1DFE. Execute the program. So we use MOVW R0 0x6398 and MOVW R1 0x1DFE. So we use the logical OR which is OR R2, R0 and R1. So the value of R0 we get 0x6398 and the value of register also we get the same value which is 0006398. So the second one we get the value of R1 in register which is 0x1DFE, and in the register value also we get the 0001DFE. So the R2 value are get when we perform a logical OR of R0 and R1. So when we use the logical 0 R0 0x936398 and we use the logical OR of R1 which is 0x1DFE and we get the answer of the register value of R2 we get the 0x00007FFEE. And also that the also this So as the question of number 5 is write a program that copy 12 bytes of data starting from memory location 04 0x4004 to memory location starting 0x4004 Set manually the content of memory in 0x4004 until 4004 to be 01, 02 and so on. Run the program and comment on the result. So this is the code that I have been done, and there are no error in it. So we go to the debug. So the first one is MOV R0 equals to 3 because it is 1 to 12 byte and it is 1 to 12 byte. So meaning 1 byte are equals to 4. So as you know 1, 2, 3 and 4. And so in 1 to 3, so that means we must use 3 times to get the 12 byte. So we go to the first. So the value of R0 is 3 because it is counter to 3 times. So the value of R1 equals to 0x40040000. So this is the register address into the register that I have made. So LDR R2 0x40040020. So the value of this R2 also equals to 040040020 because it's registered addressing. So this one, it one LDR R3, the value of R4 we get into the 4 and store into the R3. So that means it want to set it manually. So the starting address I will get here 40040000. So you want to set the memory 12 byte. 1, 2, 4, 5, 6, 7, 8, 9, A, B, C. So the value of RT also are stored and it will be 0102. So the value of R3 are 01, 02, 03 and 04. So in the memory also 01, 02, 03 and 04. So the value of R2 also store and go to R3. So means the value of the memory also in something here. So the memory in this one are 01, 02, 03, 04. Means that the memory of this are stored in this one. So in 1 to 12 byte, so we want to use it 3 times. So we go for the 3 times because we use the reduce counter. So if the counter is equal to 0, it will be n. So if they not equal to 0, the counter is not equal to 0, so then it loop again. So it also continue 05, 06, 08, 09, 05, 06, 07, 08 until 3 times it 1 because you want 12 byte. So So the 12 byte we get here until 0C. So we get 08, 09, 08, 0B and 0C. That's all for the question 5. So the question of number 6 is write the program to compare data in num into register R2. If the data is greater than 5, store the data in memory location of 0x40020000. Otherwise, add the data with 0x060 and store it into memory location of 40020010. Before that, set the number with the value of 3. Use the EQU instruction. Run the program and comment the result. So this is the program that I have been done. So we try to remove it if it has the error, so no error in it. So we use a debug. So we use a LDR R0 for 0020000 to the register addressing in the register. So the value of R0 will be 0x for 0x40020000. Same with the value of R1, we use the register addressing for 0020010. So the value of R1 also 0x40020010. So the value of R2 equals to num. Since that I have used num equals to 3, so the value of R3 equals to 3. So why we use LDR? Because when we use another, it has an error in it. So we use R2 equals to num, so the value of R2 equals to 3. So which means 0x00000003. And we use compare. If R equal R2 greater than 5 or less than 5. It is a greater than 5. It will go to the store B, R2 and R0. So the memory of R0 will go to the R2. So if it not less than 5, we use B as high, which means the store. So if it less than 5, we use add R2 0x60 and we use store B into store the value of R2 into the R1 memory. So the value of R2 are R1. So the value of R2 is less than 5. So the value of R2 equal to be 0x00000063. And after that, it will store the R2 value into the R1. So the value in the memory addressing 63 are the value of R2 into store into the memory of R1 when we use the starting address of 0x40020010. That's all from the question 6. So all the questions that have given have been done. So the conclusion is I can write a simple assembly language for a microcontroller using a data transfer and data processing instruction and addressing mode. Also, I don't know how to execute the program using an ARM or simulator. That's all for me. Thank you.